Hello everyone, welcome to PlayCanvas Office Hours, where we work through problems posted by community. I'm Steve Now, always known as Yasta on the forums, and today we're looking at a thread where Ronan is trying to take a Unity tutorial for head bobs in first person movement and adapting that tutorial to use in PlayCanvas, and they run into several issues about this. And I thought this would be a good video to do because it would allow me to talk about the differences and similarities between Unity and PlayCanvas in terms of like the engine architecture, difference between C# to JavaScript. There are some sort of minor differences to be aware of. Or say some minor, some big changes to be aware of, and also to use as a base if someone else wants to take a different Unity tutorial and adapt it for use with PlayCanvas. Okay, so the tutorial they're using is from Hero 3D, and it's basically a quick guide on how to do FPS Bob, where in first-person shooters, your head bobs left to right, effectively, and up and down. And for this, we're going to take a fork of, the first-person movement tutorial, which allows us to move backwards, left, right, and use that as our base. So we go forward again. We fork this, call this Unity head bob. And while that's loading up, what they've done already, they had a stab at this already by converting it the code that was shown in the YouTube video to JavaScript and using PlayCanvas syntax, but it's not quite there. There's some parts are missing. We'll go over, so we can use that as well as the base, and also talk about and go through all the issues that it has and how to fix them and why you have to make these changes. So let's go back to this. So go to the editor. That's fine. First of all, in the tutorial itself, there is a change that we have to do where they put in an extra empty entity to hold the camera between the player and the camera. So we're going to do that quickly first. So remember, we just got player and camera. So what we're going to do is do an empty, call that camera holder. Oh, that's not how you spell camera. Still not how you spell camera, but we'll get there. Camera. There we go, camera holder. And that is currently at 0.5, so do it at 0.5. And then move the camera to this. Okay, so we've now got the same, effectively, the same hierarchy as Unity tutorial, which is great. Okay, so let's grab this, which is head bob controller, couple that, and use that as base. Oh, just to also let you know, I did have I did speak with Ronan on the threads, going through like the issues one by one and trying to correct it. But I thought it'd be a lot easier to do this as a video, especially if I'm doing the whole thing. So let's go to this scripts and create a new script called head bob controller. Jumps there. Copy all, paste. All right. First of all, let's get rid of these extra new lines because we don't need them. So as I'm doing this, it's worth noting that they've done a pretty good job already, actually, converting some of it. They kind of got the logic in there right. They correctly saw that we don't have like serialized fields in the same way as Unity. So go back to here. There's a bit where they do serialized field where they expose the variable out to the editor so you can tweak the values in the editor. But instead we've got attributes. So they've correctly taken all those serialized fields and put them as attributes, which is a great start. So let's put this in, goes up and running. Almost there. I think one more line. No, perfect. End of the thing. So let's save that. Go back to here, parse it. And we've got our first error, which is uncaught reference error, effectively not defined. And that's because somewhere along the line they've created these the class or the script type, script type variable. And from here, this is where we add our functions. So we've got the initialize and update functions. They added their own function called check motion, which comes again from the tutorial. But here, for some reason, they use vec3. So I assume that's some sort of typo. So that's an easy fix already. Fix that. And let's reparse that. So should have all attributes. Pause again. Come on. There we go. There's all attributes. And we add that to edit control. So here we're going to do all our things. So we assign the camera and we assign the holder. Okay. So you notice here there's underscore in the variable name that's used up here. And again, this is because in the tutorial that had Unity, the YouTuber, I guess, the YouTuber or developer decided to use underscores to denote to show that it's a private variable. And actually, in PlayCanvas, not PlayCanvas, in JavaScript, we technically everything's public, but as a kind of style, as a common style, is to use underscore before the variable name to show that this variable or this property of the object should not be used externally from the object functions themselves. And this is generally like a visual way of showcasing that it's private, and I'll say that private in quotation marks. Technically, you don't. If you want to get rid of the underscore, you can set an extra attribute called title. So it's an extra option property, a property for the attribute called title, and you can do this effectively if you want to keep the underscore in the variable name. So if I reparse this, for example, you can see that goes with the underscore. But for the moment, let's leave it as is and keep it as close to the original tutorial as we can. That's a reference point. Okay, so that's that in. We're going to launch this, and we should immediately see a whole bunch of issues. So we've got our first issue. Let me move my cast out of the way. Camera's not defined. And what the issue is here is that in C#, you don't need to use the this you don't need to use the this property or this keyword in your class, because it's implied that the variables you call or the class functions you call are in the class scope. But however, in JavaScript, you have to explicitly put in the this keyword into it. Say I'm looking for the property in this class. So let's do that for all the places where we use camera and start position, and also all the functions. Same applies for the functions as well. So again, this is a relatively straightforward fix. Controller, boost speed here, toggle speed here, play motion here, display motion here, frequency, camera, camera holder here, and camera holder. So I think that's all of them. I probably missed one or two, but we'll find out soon enough. Refresh that. Enables defined. I knew you missed one. There you go. Okay, so now we're getting another issue where is cannot read properties of velocity. So in this case, it's saying that this property of this object is undefined and therefore can't find velocity. And the reason, and this isn't like these things, we need to just find a reference to the controller, but in the tutorial, the controller reference is refers to the mono behavior character controller that's used for the first person movement in here. So in PlayCanvas, the scripts aren't actually a component. They belong underneath the scripts component, as we see here. So if you go to here, this is a component, collision is a component, rigid body is a component, script is a component, but script types, they are underneath the script. So to get access to the script, we have to go through the script component. Sorry, we have to get access to script type. We have to go through the script component of the entity. We don't have a character controller in this example, but the closest, as a character controller represents the character movement, so how it moves, the controls, etc. The closest we have, so what we will use is first person movement instead. So let's go to here and create a reference to it, equals, and this is how you go about getting the script type reference. So it's this. So because it's on the same entity, we go through the entity object first, go through the script component, and then the next part is to find the script name to refer it by. And the script name is effectively this string up here. And do that. And now we have a reference to the controller. All right. Along this vein, along the same lines of thought, we're trying to get the velocity from the controller script. But in our case, we don't actually have a velocity property in this script type, and therefore what we can do instead of getting velocity through the script, we can get the velocity or linear velocity through the rigid body. So it actually, and as the rigid body belongs to the same entity on as a script. So let's see the rigid body. What we can do instead is get the linear velocity from that component instead. Let me see. So it'd be this entity. Actually, you know what? Let's do a new variable. So var velocity equals this dot entity dot rigid body component, and then we want linear velocity, which is a property, which is fine. And we're going to do that for x and that for y. Okay, so that's step one. And in this particular case, what we're using the velocity for is to know how fast it's going in a straight line. We don't actually need the direction of it. We just want to know how fast it's going in a straight line. And if it's less than the toggle speed, and the controller is grounded, then we do this play motion, foot motion thing. So let's see, the best way I can do this is new vector, blah, blah, blah. What we could do instead, rather than using a property for this, we're going to clone the velocity. So we get a new object, we get a new vector-free object that is the same value as the linear velocity. And then what we're going to do instead of setting it, go set the velocity to .y to 0. And then that way we can change this to be fast speed. So local variable, we don't need it as a class. We don't need it as a class property. And do velocity magnitude, except we don't actually have. So we don't have a magnitude property on the vector free. What we do have instead is length, which is a function that calculates the length of the vector, which is going to be our speed. And now we could do this. Check speed against toggle speed, which is fine. We don't have a grounded property on the of the first person movement because there's no jump. So we're going to comment that out for the moment. If Ronin does add jump later, then they can add this back in along with the check. But for the moment, we don't need it, so we comment that back out, which is fine. So that's good, I believe. So let's run that again. So we'll go back to this. Update. Focus. Sorry, what's it again? So camera. What's the error again? Focus target is not defined. Oh, whoops. Forgot to do this dot focus target. So it's calling the focus target function, which is fine. Okay, back 3 not defined. So let's go down to there. Looks like they're trying to create a new vector object. So this is the incorrect syntax. I'm not quite sure what they're trying to do here, but this is fairly easy enough to fix, which is phi plus. So create a new vector-free object that takes the transform position x, y, and the camera holder local position y, and takes the current x position, the current y position plus the camera holder local y position, and the current z position. So in PlayCanvas, we don't have a transform object, and the transform object in Unity covers the position, like rotation, scale, and allows you to do a bunch of operations on it. In this particular case, because we only want the position, and we don't even want the rotation, because we want the just because we want the position, we can get that from the local entity through our get position and get local position functions. So let's do that now. Let's say current position equals this dot entity dot get position, and we get the camera position as well. So camera. What am I doing there? Camera local position equals this dot camera holder dot get local position. It's fine, and then we're going to reconstruct our new position using this. So that goes, and we get the camera local position. Awesome. Okay, so so another issue here is that in C# you can have operator overloads. The forward is a vex3, and they want to multiply it by 15. But in JavaScript, we don't have operator overload, so we have to go through this with a function. So how are we going to do this? For this, for the easiest part, we're going to clone the forward position of the camera holder. So do camera holder forward, which equals, that's not equals, this dot camera holder dot clone, and then we're going to multiply it. I think it's mole scalar. Was it mole scalar? Oh, it doesn't know it's vec3. Just makes it a bit easier because I can't remember the syntax. We're going to say at type, I say it is a PC vec3, which means that now I can access the IntelliSense because it knows what it is. Mole scalar. So this takes a number and multiplies all accesses by this number, and then now we can use, and now we can add this. So again, this is another operator overload that doesn't exist in JavaScript, so we have to do this manually. Manually, do this through a function. So do add camera holder forward, and there we go. Right, let's run to our next problem. Vec3 not defined. Where's that coming from? Okay. Oh, whoops. Let's go through the PC namespace. So or the PlayCanvas classes are under the PC namespace effectively, or PC object. Okay, so can't read product reason why. Wait, you can't read why. Current one. Oh, whoops. My bad. Okay, here we go. So now we're running into our next problem in the update, where is look at is not a function. So a common style in C# is to have all your function names begin with a capital letter. However, in JavaScript, the common style is to have all your function names in lowercase. So I won't change these for the moment, but it would mean that generally any function you call in JavaScript that's in the standard library or even in our engine is going to start with a lowercase letter. So we just change that to this. Oops, and that will fix that issue. Okay. So nothing moves. Interesting. Okay. Why does nothing move? So update, check motion, play motion. I wonder. Oh, wait, toggle speed. Okay, yep. Velocity. Let's take a look. So check motion, blah, blah, blah. Camera look at. What are we changing the position of? So taking the camera. Oh, that's interesting. Is every update is looking forward, which is probably not what we want. So actually, what we're going to do instead is, I think the issue is that the first-person controller is trying to move the camera, but we want the camera to be controlled by the head bob. So what we're going to do here is, instead of the first-person controller controlling the axis, the rotation of the camera, we're going to have it say change the camera holder. And there we go. So there we go. Much better. Okay, so now we can look around and we run into our next issue when we move, which is, again, same sort of thing. We'll create a new vector. So it is bar pos new PC.vec3. And again, we're going through the same parts here. We're going same parts. We're going through the issues where this is, I can't remember if it's a C# standard library or Unity thing, but this doesn't exist in JavaScript. We're going to use the standard math libraries in JavaScript, which I believe is the math.object and that sign. So again, lowercase for function names, uppercase for class names. Time object doesn't exist in PlayCanvas. Unity, I think in pretty much you have access to this global object called time, and allows you to get the time since the app started as well as delta time, but we don't have that in PlayCanvas. So what we're going to do instead is track that ourselves in this class, which is fairly straightforward to do. We're going to create a new property, and then every update, we're going to add delta time to it. Easy as pie. There we go. So that's fine. Something I did notice here as well, is probably worth mentioning. If we're doing this thing where we're doing the start position equals new vector, then start position equals the local position of the camera. And this is a couple of things to note here is one, no, say not one. In C#, you have the notion of structs and classes where you can where by default they will copy by value or copy by reference. So the vector frees in Unity are of a struct type. And that means that when you do things like this, where you assign it to a new variable, it's copying by value. Whereas if it was a class, which it isn't, so let's say hypothetically it was a class, this would copy by reference in C#. In JavaScript, every object is copied by reference. You can't copy by value, or you can't copy an object by value, which is problematic and actually causes a lot of confusion for a lot of developers coming from Unity. So really, the start position here, and they want it to be the local position of the camera, we're going to have to clone the local position so that we get a copy of the position rather than a reference to the local position of the camera. Because that way, this value won't change unless we change it. Rather than change it, if it was a reference, it would mean that we're referencing the local position of the camera, which would potentially change every frame. So that's quite important. That's a quite important thing to note when looking at Unity tutorials or looking at C#, where when they deal with like vector frees, they're all copied by value. You get new copies when you do the assignment operation. When in JavaScript, you cannot do that. Okay, so we've got this. Okay, so we're doing pretty good so far. As we look more through the functions, so while we're here and talk about local position, this doesn't do what you may think it does. I mean, when you look at this say logically, you may think that you just check in if the start position is the same position as local position. Whereas what we talked about earlier, where you're dealing with references to objects, this is actually checking if this object is the same object as this one, as in either point to the same reference, or so it's the same object through the reference. So what we're going to do here instead, first of all, I'm going to format that because that is not quite right. There we go. What we want to check is if there is occupying nearly the same space, so whether they're nearly in the same position. So the best way for this is to basically check to do a standard distance check between the 2 points and then see how big that distance is and if it's more than 0.001, for example. So what we're going to do here is create a new variable, which is, let's say, difference between points. Let's call it point difference. Let's call it a point difference. Positive. Equals new pc.vec3, which returns to be a vec3. Now I have to do subtract between two vectors. So I'm going to take two vectors and subtract them from each other. So this dot camera and get the local position, and this dot start position. And then what I can do here is say pos.diff and do a length squared, because we don't actually need to know what the actual distance is. We just want to know if it's more than 0.0 something. And this saves us a square root effectively. So it's more than, where's the more than? 0.001, maybe 1. Let's do 1 centimeter. Let's do an extra 0. Then if it's more than that, then return. Oh no, if it's less than that, then return, because that was previously equals. Otherwise, do this bit of logic, which is lerping the camera position towards the start. So what we're going to do here is, first of all, create a new vector to use for new position. New pos equals. So create a new one, and we want. So go back in. This syntax does not exist in PlayCanvas. They want to lerp between 2 points, but in C#, in Unity, I believe they have a vec3.lerp global function, but in our case, we have to lerp on the vec3 object itself. So we're going to do new pos.lerp. Oh, whoops. We'll put that in. So it's like .lerp. There we go. Lerp this camera get local position again. This dot start position, and do 1 times time.dt. So again, time doesn't exist in here, so somehow we need to get dt into this. So let me fix this up first. Let me do time.dt for the moment. So we've got placeholder. So placeholder, and then we set this new position to the camera. So this dot camera dot set local position. Okay, somehow we need to get delta time into this. So where's this called? I believe this is called in the update loop. So that's great. Delta t is passed in the update function. So we pass delta t into the function for reset position. Get that as a parameter. And that should be good. Okay, so let's see how far we've got with this. Okay, now into play this. This play mission is not a function. So I actually had a quick look at this. They don't actually, in the video itself, they don't refer to play motion at all. But in the first comment, they said, "Oh, I forgot to show the play motion method, but it's super simple." So we're going to take this function and let's put that into our code here. So we get a new function equals function. I would only say the type because JavaScript doesn't need you to, doesn't let you set the type, quite frankly, which would be helpful. Motion, this dot camera. Okay, so again, we're going to the point where it's trying to add a vector3 onto another vector3, but the problem is we don't have operator overload, so we need to create a new vector3. It's a new position. We can create a new vector3 for the new position, which is pretty straightforward. And what we're going to do here is, actually, you know what? Rather than create a new vector3, we're going to clone the local position on the camera and then add to it. Go local position, dot clone. And then add motion. And then set the new position to the camera. And see. And get rid of that line. Okay. I think we're in good shape now. Oh, that is not good shape. So what happened here? Let me try that again. So move forward. Oh, that is not good. Okay, so I have a feeling that there's probably a nan that's going on here. So let me take a look at this. Where have we gone? First dot y, first dot length, squared. Okay, so let's work backwards from this. Let me grab console. We're going console out motion. I see if there's a nan, not a number in that. So move forward. So yeah, so nan. So where is that getting from? So motion is being called here. It's using this vector3. So something in here is going wrong. What's going wrong? Ah, now I remember. So I believe, yeah, here's a problem. So it's referring to this dot amplitude property, and I thought that was supposed. So this is referring to this. This is actually undefined. So this whole calculation goes to pot. Basically, this is a nan, and that's because this was named to amplitude.start for some reason. So let's rename that to that. Refresh that. So now enable amplitude, frequency, camera holder. Refresh this. Here we go. And then we've got a head bob. Fantastic. So hopefully this, let's just go for a recap. The main things to point out are copying by value doesn't exist for objects in JavaScript, so you have to consider clone. Oh wait, I didn't clone up here. So that was meant to be a clone. So going back to that point to cover, copying by value of objects doesn't exist in JavaScript, and therefore you have to, if you want to keep a copy of a vec3, which is the most common case, you're going to have to clone it. And a lot of our objects in PlayCanvas engine will have a clone function for that purpose. So materials have it, I think. What else has it? Material has it. Vec3 has it. Vec2s have it. Entities have clones as well. So you get the idea. And also, when you refer to anything to do, any property that's specific to the script, so there's like the attributes, any sort of extra properties you set yourself, they have to be explicitly, or call functions in the script, you have to explicitly use the this keyword. What else was there? And also, unlike Unity, scripts are not components, or and therefore you have to access them through the script component, as we did with the controller here. Apart from that, the only other stylistic change that I will do, but won't do in the video, is change all these function names to be start with lowercase to keep it uniform. Because you see here, this is lowercase for a specific reason. It's lowercase, and that's because in JavaScript, generally, all function names begin with lowercase. And I think that is about it. Oh yeah, and operator overloads. JavaScript doesn't have operator overload, so you have to call functions and everything. So again, this comes down to working with vec3s. You have to do things like call add, subtract two, when you're doing subtraction between two vec3s, or check in if they're equal to each other. You have to go through a couple of extra hoops, unfortunately, and that's just the nature of JavaScript. So what I'm going to do, I'm going to wrap this up, create a checkpoint, wrap this up, and share this out to the original user along with this video. Thank you for watching this far, because this is actually quite a long one compared to our normal videos, and we'll see you next time. See you later.